Since July, the world has been watching 3I Atlas speed through our solar system. But in October, just as this now infamous interstellar object started to get close enough and bright enough to Earth to study properly, our view of it was blocked by something else, rather close and far brighter: our Sun. The ground-based telescopes that had been tracking its every move for months were now blinded at a most frustrating time. We'd just begun to study its strange molecular ratios, saw it change color twice, and even spotted a strange and unusual sunward tail that some suggested might be evidence of artificial propulsion. Meanwhile, subjected to the sun's intense radiation and moving at a staggering 68 kilometers per second, it wasn't clear if 3I Atlas would even survive the journey around our star. But all was not lost. Out in space, a fleet of probes, telescopes, and even Mars rovers were keeping a keen eye on 3I Atlas as it dived towards perihelion. Would it make it out the other side? Disintegrate in the sun's searing heat? Or would it do something else completely unexpected? I'm Alex McCohen, and you're watching Astrum. Join me as we dissect the stunning new data from 3I Atlas's Mars flyby, find out what happened behind the sun, and analyze the smoking gun evidence from a South African radio telescope that could settle the debate about whether we are looking at a volatile comet or something that is intelligently navigating the dark. Before 3I Atlas even vanished behind the sun, it gave us a warning that it was no ordinary comet. In late August and September, NASA used their SWIFT observatory to watch 3I Atlas as it approached the sun. SWIFT is designed to spot gamma-ray bursts, but its UV capabilities allowed it to see things invisible to the human eye. In this case, the glow of hydroxyl, or O radicals. These molecules are the broken fragments of water ripped apart by sunlight. And what SWIFT detected was a massive surge in those hydroxyl radicals. At a distance of 2.9 astronomical units, nearly 3 times the distance from Earth to the Sun, 3I Atlas was dumping water at a rate of 40 kilograms per second. To put that in perspective, that's the output of a fire hose running at full blast. For a comet this far out, where temperatures are still freezing, this was shocking. Standard models suggest water ice shouldn't sublimate this aggressively until it gets closer to the Sun. This fire hose behavior hinted that 3I Atlas wasn't just sublimating water from its surface, it was likely ejecting icy grains into its coma, which were then melting independently, vastly increasing the surface area. But before we could find out more, this comet dipped behind the sun and disappeared. Throughout October 2025, Earth-based telescopes had to take a break from watching 3I Atlas. This was the worst possible scenario for astronomers. The most exciting moment of the comet's journey was happening on the opposite side of the sun from us. When warned by the sun's radiation, it would be at its brightest and would be outgassing violently. But while Earth may have been blind, we already have plenty of probes and telescopes in the deeper reaches of the solar system, some of which were perfectly positioned to watch the show as the comet made its closest approach to the sun. A new study led by Qiang Chang from the Lowell Observatory in Arizona and Carl Badams from the U.S. Naval Research Laboratory aggregated data from 3 specific spacecraft: Stereo A, SOHO, and the newly launched GOES-19 satellite. These 3 spacecraft use coronagraphs to block out the sun's disk, creating an artificial eclipse. Usually they hunt for solar storms, but in October they were hunting a comet. And what they saw was a metamorphosis. For months, as 3I Atlas approached the inner solar system, its brightness had been steadily increasing. Astronomers measure the rate at which that brightness increases as a power of an object's distance from the sun, or R. Before October, 3I Atlas's brightness was increasing at a rate of roughly R to the negative 3.8. That is a respectable rate for a comet, indicating active sublimation of material from its nucleus. However, inside 2 astronomical units, the brightness slope didn't just steepen, it went almost vertical. The new data shows a brightness scaling of R to the negative 7.5. That's a huge increase. The comet was shedding mass at a rate that defied standard models for a simple, dirty snowball. It was bright enough that by the time it emerged from behind the sun, even amateur astronomers were able to image it from Earth. These are some of the images taken of the 3I Atlas during this time. In them, you can clearly see a bright coma streaking out behind the comet, although the core of 3I Atlas itself is a little harder to make out. They were taken by astrophotographer Paul Craggs, who used a Dwarf 3 smart telescope from Dwarf Lab, a telescope I've been trying out myself recently, as they've kindly sponsored this video. I like this telescope a lot. It's really proficient at this kind of deep sky imaging. Its live stacking helps it build up clear and detailed deep sky images in just a few minutes, especially impressive for such a compact smart telescope. It was really easy to set up. Once I got it on its stand, it quickly oriented itself using the stars, so it was simple for me to point it at the stars and comets I wanted to image. I also liked its portability, as I didn't want to be lugging around a heavy telescope on a cold winter night, but the Dwarf 3 is light and easy enough to use that I didn't have to worry about that. Although the best window for imaging 3I Atlas has already passed, if you're looking for a very good value smart telescope to help you take images of other beautiful birth of a solar system moments, from nebulae to star clusters and any future comets that might be coming past, then try this one out. Scan my QR code or use the link below. Then use my code ASTROM5 at checkout to get 5% off. The most telling detail about this newly brightened comet, though, was the color. For months, observers saw 3I Atlas as red, typical of dusty, organic-rich surfaces like those on Oumuamua. Then it turned green to observers on Earth, as I mentioned in my last video on this comet. But the Solar Observatory saw something different. Through the filters of LASCO and Core 1 coronagraphs, Chang and Badams reported that 3I Atlas appeared distinctly blue relative to the Sun. A blue hue in a cometary coma is the signature of specific gas emissions, fluorescence from carbon monoxide and nitramide radicals. It suggests that as 3I Atlas plunged towards perihelion, it shed its dusty red outer cloak. The intense solar heat penetrated that protective layer and began boiling off volatile ices from deep inside the comet. The real comet, the blue, violently outgassing engine inside, only revealed itself when it got close enough to the sun. But these solar probes weren't the only ones watching. Just before the solar encounter, 3I Atlas paid a visit to our little red neighbor, passing just 0.19 astronomical units, or about 28 million kilometers from Mars. This was a cosmic stroke of luck, offering a unique opportunity for the fleet of robots currently exploring the red planet to observe. NASA's Mars Reconnaissance Orbiter swiveled its HiRISE camera toward the visitor. Now, HiRISE is powerful enough to spot a coffee table on the Martian surface from its orbit of 200 to 400 kilometers above. If anything was going to be able to get a resolved picture of the nucleus, it was this camera. But the US government shutdown affected many of NASA's departments, meaning it took weeks for the pictures to be published. The long wait to get a hold of these images sparked conspiracy theories that NASA had seen something unusual, perhaps extraterrestrial in origin, and were withholding it from the public eye. The images finally released by NASA, nearly 6 weeks later, were underwhelming. They show a fuzzy, unresolved blob. Even from this distance, the nucleus was hidden deep within a shroud of gas and dust, measuring 1,500 kilometers across. Although we didn't get a beautiful, pristine photo of our interstellar visitor, at the very least, this non-detection may help scientists pinpoint how large 3I Atlas really is. But we already know from observations made by the Hubble Space Telescope that it is likely no more than 2.8 kilometers wide. But MRO wasn't alone. ESA were busy imaging 3I Atlas with Mars Express and the ExoMars orbiter, and NASA's MAVEN orbiter used its UV spectrograph to image the comet's hydrogen envelope, revealing a massive cloud of gas extending far beyond the visible coma. Most incredibly, the Perseverance rover sitting in Jezero crater, fresh from discovering what might be evidence of life on Mars, pointed its mast cam skyward. In the resulting long exposure images, 3I Atlas appears as a faint, ghostly smudge drifting among the stars. These images may not look like much, but they are truly groundbreaking. This is the first time we have ever imaged an interstellar object from the surface of another world. And then, it was the moment we've all been waiting for, perihelion. As 3I Atlas emerged from behind the sun in November, panic spread through the astronomical community. Harvard astrophysicist and avid 3I Atlas commentator, Professor Avi Loeb, suggested that the comet had fragmented, that it had exploded into 16 pieces. It looked like our chance to observe this rare interstellar visitor might be over for good. His hypothesis was fueled by calculations suggesting the comet's mass loss was unsustainable. With the brightness surging so intensely, some models predicted the nucleus must have disintegrated to provide that much surface area for sublimation. However, new observations from the Lowell Observatory and the Virtual Telescope project have calmed these fears.